Well, hello and welcome to another episode of the JUXTCast. I'm Henry Garner, and today I'm joined by David Kelly, Chief Scientific Officer at MKM Labs, a Linux Foundation initiative. David's been an independent consultant for many years, delivering advanced financial modeling, risk management, and model governance for major banks and financial institutions. And he's written several books, including the Handbook of Model Risk Management for Vendors. He's also been very active in the FinTech Open Source Foundation, also known as FINOS, winning this year's Best Newcomer Award. And ahead of the FINOS conference in New York, which is later this month, October the 21st and 22nd, I'm very pleased to have David here for a chat. Hello, David. Welcome.
Hello. Thank you very much for that welcome.
So let's dive right in. So for listeners who may not be familiar with the concept, how would you define model risk in the context of banking software? And amongst all the various risks we face in financial technology, why does model risk deserve a special focus?
The main reason is that when models fail, it is always brutal, and the reason is because they tend to be built by people unable to communicate to senior management. So when they go wrong, it's very hard to know why, but the impact can be foundational. Is the best way to consider it. So a good example is in 2008, it's called a Sabre model, which is the one that calibrates volatility surfaces. It collapsed. It completely failed. So you have whatever trillions of swaptions unable to be priced during a market disruption event. So it's those things, and of course it takes years to figure things out. So the reason why we have model risk governance is to, in many ways, provide assurance that the model's been built correctly, and also they're being implemented appropriately. So this is when they are attached to, let's say, a product or something like that, and also to be very clear when models fail. There's a very good quote when it says all models fail, but some are useful. And we have to remember that a model is a simplified version of the world, and therefore it's unable to pick up every single nuance. So the first sort of event that I remember with model risk was in 1987 when we had the Michael Fish. It's in my book.
Yes.
Michael Fish says, "Don't worry. There's some lady in Sevenoaks saying la la la." But don't worry, there's no hurricane. And Sevenoaks became One Oak overnight.
Mm-hmm.
And that's just a good example of sort of not appreciating where these models can get things terribly wrong.
And when we say model, what are we talking about? Is it a spreadsheet, an algorithm? Is it something
Yeah.
abstract?
So fortunately, our American colleagues at the OCC 2011 made it very clear what a model is. It's a remarkable piece of document. It's called the SR117, and you'll hear model people sort of using this terminology. But a model is very simply it has three components. It has an input, and it has an algorithm, which is of a mathematical bent, can be statistical or could be stochastic or anything like that, and it has an output. So an Excel spreadsheet isn't really a model. You really do need to have those sort of three components: a sort of staging component, a processing component, and then an output component.
I'm with you. And you mentioned when these models go wrong, it can be fairly catastrophic. I'm wondering, what are the key ways in which we can mitigate those risks? How can we demonstrate a kind of model risk competency?
Well, I think the first thing is, people can build things in isolation. People can be quite academic in the way they build things, and what we do is a sort of process of validation, which is sort of the stepping stone up to model risk, is to ask sort of pertinent questions. So, why have you chosen that type of distribution, or why have you chosen that mathematical formula? Because funny enough, most formulae or processes are in the common domain because they tend to come from academia anyway.
Right.
So why did you choose that one and not another one? And have you thought about X, Y, Z? So it's very much where you're trying to get to is to say, okay, where is my model weakness? And this is very difficult for vendors to do this. This is because it's like, well, my model's perfect. It's better than anybody else. And it's just, well, no, you have to, comes back to that quote around all models are wrong, is you have to say, look, the model's not going to work in this environment. And therefore, one should limit its use. And it's, that sort of weakness and limitation is extremely important. There is a tendency in capital markets to what we call shoehorning. This is when you've got a product and you go, well, it's got all these bells and whistles. We'll just use that model across there. So a very good example is, um, Black Scholes is a perfectly good model, right, for options and things like this, but it's not good for Barry options as a silly example. But what it says is that you shoehorn these things in. Therefore, you need to know what risks are not being captured by the model. Model's fine. It's just been not used. It's been used in an inappropriate way. So lots of the issues that we have is just people not using the models correctly.
And is this analysis of model risk something that happens retrospectively? It sounds like the model's already been produced, and then you're looking to see whether it's applicable in the circumstances. Is that
Yeah,
correct?
it has its own. Obviously, a model has its own life cycle. So you go from business, we have a business case or something like that, through to development, testing, integration, and then um, you know, sort of changes and la la la, and then it just gets decommissioned. So the model risk is sort of involved in all those components, and sometimes it's light touch, particularly at the beginning. When you have this difference between a model that works in theory and a model that's put into practice. So a lot of the times, a model is built in, let's say, Python or even a spreadsheet, but is actually coded in C# or C++ or something like that. And I quite like that sort of separation because you're testing or you're questioning whether this thing works in theory, and then it's well, does it actually work in a production environment? And the two are very, very different. So, having that two-step process just means you get the sort of the theory out of the way, and then it's all about, okay, let's have a real life transaction or a portfolio trades, etc. Does it actually do what it claimed to do initially? And I think that's so. Yes, it's pretty well involved. Whenever you have changes in the model, it does go through a process. The the key to this whole exercise is what we call proportionality, which is you've got to show value. If you are a tax, which a lot of risk functions can be seen as, then you're missing the point. You're there to provide assurance and hopefully avoid catastrophe, or at least when things go wrong, you know what to do.
Is that when the value of good model governance is evidenced? It seems quite hard to demonstrate the value when everything is working well and there aren't any
Yeah.
fires or massive
Well,
catastrophes.
the nice thing. I mean, we used to joke when I was in market risk is that it feels like every day there's one in 100-year event. So, they come around. I think it's human nature, and I think it's the nature of because of the complexity of capital markets and its position as systemic risk for society. It does go through these cycles a lot more frequently than you would imagine. And it's like oh gosh, what's that film? It's like Merlin saying, when's the next catastrophe going to come or something like that. And he goes, always when you least expect it. And I think that's how we kind of feel it. So like, we have such a track record of cock ups, if that's the right word, that people can see that maybe we should take this seriously, and that's what we sort of rely on. But you have to be, as I said, you have to operate as a risk function rather than a box ticking exercise.
And what you said about every day there being a 1 in 100 year event, like where do those events come from? Like what's triggering these events? It sounds like the environment is quite volatile. Like there's a lot of
Yeah, I think a lot of it is just there's a sort of interconnectedness about particularly capital markets. and particularly credit. And we are talking about gazillion trillions of assets. I actually don't know the number now. I think it's about 500 trillion for derivatives only. So you just there's just so much going on, and a lot of it is linked to things like oil is very much linked to the geopolitical situation, which, as we know, is quite volatile. A lot of it is connected to sort of emerging risk, which is around climate and hazards like flood, where it's the risk has always been there. It's just people's perception of the risk is starting to shift, and that's when it comes because risk is it's not just the event; it's um, the perception of that risk and people's response to that risk, which is at times can be irrational and volatile.
We've talked previously about the impact of the interest rate changes came in a few years ago. Like these environmental factors can trigger quite significant flux, can't they, in these models? Can you say more about that?
Yeah, I think that the biggest one that we saw recently in the last couple of years was when inflation spiked, um, and that was sort of a hangover from the COVID lockdowns and stuff like that. So again, that was quite a sort of a momentous event.
Mhm.
It wasn't clear how the world would respond, how world will snap back, and in many ways, people underestimated the supply chain issues. So inflation, I mean, 10% inflation. I've spent a lot of time with economists doing or actuarial type sort of functions, coming up with worst case scenarios. 10% was never on the list. It just was never. And then we went, we went there literally within a couple of months. So that's a classic form of dislocation because particularly in part of the world that I'm involved in, which is in pensions and long term asset liabilities, that was just like okay, we're this is a mess, right?
Hmm.
This is not good, and it took a while actually for and we all know. I mean, you go to the shops, you know that inflation never really recovered back to anything sort of sensible. So I think those kind of things. I think the sort of level of borrowing, government borrowing across the world is going to make things a lot more pivotal, a lot more sensitive. So we'll see. We'll see in the next couple of years how that. Yeah, and also nobody would have imagined that gold was at this level. It's insane.
And are these failures of kind of model governance further up the pipeline, as it were, that these things hadn't been foreseen, that 10% was never part of what anyone was
Well,
factoring in?
yeah. So the issue with risk, and particularly when you're doing stress testing, and again, climate is a good example of this. It has to be bad but credible. Because if you can go, look, the whole world, we're going to have an asteroid and it's all over. People are like, well, thanks very much, but
Hmm.
doesn't help me, because you want to put a stress test together. People go, maybe my liabilities aren't fully covered, or maybe I should put on a hedge, or maybe I should, take the foot off the pedal and sort of diversify, whatever. So it has to be credible, and the problem is 10% was just like, well, that's just not credible, and but then here we are. So it is a funny it's a failure of it's sort of failure of model process, I suppose. So as I said, it's constantly evolving, and people, the art of this is really, mistakes will happen, and the question is how you want to respond.
And that, I guess, raises how you respond to your stakeholders or your customers if they're being impacted by decisions that the model is making in these kinds of scenarios where things are breaking.
Yeah,
Like,
a good example of that was we had with inflation bonds. We try you have to create a curve, and what you do is you take your bonds, and then you pull out the yield, and then you get some sort of algorithm to smooth it out. So you've got something that looks fairly credible. But when you have a dislocation, you realize that part of that dislocation is because things aren't trading. So you see if you you can either overfit and you just have wiggly lines across the curve, which is hopeless, or you try to smooth it to the point of irrelevance. And so we had to go back to the clients and say, look, I can't. It's not working. We're over smoothing here, and it's not looking good. We have to take some of the bonds out. We have to filter the liquid ones out, and there's about 100 different ways to do that, and we've got it down to, let's say, five. And this is what they all look like. They're all slightly different. Um, we're going to go with this one because it just feels right. Uh, please, please tell us if you disagree. Right? And the answer came back none. There was no answer returned. But what we showed them, that we had a thought process. This is the problem. We have a market dislocation. We're going to have to filter bonds out. We've come up with 5 different ways you can do that, and we've gone with that one.
Hmm.
So at least it's that level of transparency to say we have actually worked out what the problem is and we found a solution. Who knows if it's the right one, but it feels okay, feels good enough, kind of thing. And the response was very positive. And that, funny enough, that methodology did change over time. We say, well, actually now it's calmer, that we can bring more in. And we were just communicating like, we've revisited this quarter. It feels better. We're going to go with this one. And so long as the transition doesn't sort of make a mess of things, people are fairly relaxed about it.
It's quite a nuanced message to try and convey to customers, isn't it?
It's quite a mature, as it is nuanced. It's showing that we are taking these things seriously. We have monitoring processes in place. We're constantly questioning ourselves and each other, and we're willing to communicate in a way to explain that the world isn't perfect.
Would you say it's an art as much as a science?
Can be, yeah. I would say very much so. Because any risk taking it's a bit of art, a bit of hubris, a bit of science, bit of luck. And I mean, it's like when you meet some a young guy and he's done his first trade on whatever, on the coins Bitcoin, and he made money, and then he becomes the world expert on Bitcoin. That's the kind of the hubris that people have,
Hmm.
and people have that sort of hubris around being right all the time. And I think part of the model risk sort of mentality is that we're all going to be wrong at some point.
Hmm.
So get used to it. So it's quite sort of. I always think people who studied physics seem to have this pretty well locked down. That sort of mentality that 99% of the time they're going to get it wrong. And I quite like that mentality. There's some honesty with it.
You mentioned about the challenge of smoothing noisy data. And I mean, we often hear in technology about garbage in, garbage out. I'm curious about that relationship between kind of data quality and models and model risk.
Yeah. So you have to, if we take a product and a product, we actually called it, it's called a PVM, another acronym I know. So it's product valuation model. And when we came, when as we came back to the original definition of model as an input, an algorithm, and an output. So the input includes the data and its quality. So when we look at a product, we have a data quote model, because it could be a curve, it could be just could be data from ICE or Reuters, wherever, um, or it could be made up. There's a lot of manual. I shouldn't say made up. It's sort of you're kind of like, oh well, correlations 35. There's a bit of that going on. And then you've got the model itself, and then the output. So the garbage in, garbage out. The role of a model owner is to ensure that once the data gets to the model, it's in the right form and the right quality. So you have we tend to run on a like a racy types of operating model. So you've got the people who are responsible for turning the handles and getting the data and getting it loaded up and running all these algorithms. But you have the model owner who has the accountability the process works, and obviously the point of escalation. So you have a model that's running the data, then you've got the model doing it. But you also have the output. And this is when people sort of underestimate the output, because people say, "Oh, it's the output." They just stick it on a whatever dashboard and hurrah. But we know in this world, if your output is based on some distribution, I mean, particularly in AI, it's a probability weighted result. And but human nature kind of likes more certainty than the model will give them.
Hmm.
So, and how people interpret that number um, is part of the model risk as well. And you see this quite heavily in government, events when the sort of academic comes up with this, we're all going to die kind of sort of scenario, and then it's the interpretation by the MP who probably did, you know went to Oxford or something like that, um, doesn't understand the model, or doesn't understand what the academic is saying, and then people make terrible decisions based on that. Foot and mouth disease is probably a good example of that. So, so how your data, how your output is interpreted, particularly when it's a risk decision making, is as important as the garbage in, garbage out sort of paradigm. So yeah, so the three, this is sort of when model risk kind of overlaps with operational risk, or all the other things. But at the end of the day, the model owner owns the outcome. And I think that's the way we sort of see things. They're terrible at God bless them. They're terrible at doing operations, and they're terrible most of the time at IT. We'll talk about it in a sec. But they are good at modeling, and but how it all gets plugged in, it's their ownership.
Does that imply that it's the duty of the model owner to communicate things like confidence intervals, acceptable precision, not
Yes.
report to more
Yeah.
decimal places than is justified, kind of thing?
Exactly, and that's part and parcel of the sort of the model related type documentation. It's very much in that sort of, how does the machine work, um, rather than a typical technology spec. It's very much those sort of questions, and how does the inputs, or how does the changes in the inputs, which obviously change the output, but also how sensitive the model is, particularly if it's a calibration type thing, where it's got to land on a shape or a curve. How efficient it is in getting to that point. If it's quite a large computational thing like a Monte Carlo, how quickly can it get to something that's stable and accurate? So all those sort of considerations is a model type sort of consideration.
So let's say I've just produced a model and I've documented it. I've done some sensitivity analysis. I've communicated the kind of whether I think the model applies and where it doesn't. I produce a document and I share that with my downstream consumers of data. What's the process by which I can make sure they really do understand and they're not going to, just take a top level number and run with it?
So I think there's, as I said, there's a separation between the model and the environment in which it's been implemented. Um, so you have these. As I said, the model side is really asking whether what you are proposing mathematically makes sense.
Hmm.
You've asked all the right questions. So that's sort of step one. That you have that handover between the quant and technology, which can be problematic. Um, and we've seen in places when you build your model in, I don't know, Python, and then it's rewritten
Hmm. Yep.
because then the technology can say, well, at least I can understand what they've done because I've had to write it, which it seems quite expensive way of doing things, but I think long term it's actually, it pays dividends. So you have the handover, and of course, things running on your desktop is different. You know, having one sort of structured note is different from having, say, 10,000 structured notes having to run in a 4 hour window.
Hmm.
It's just different. So yeah, so what tends to happen is you get this handover, it goes into production, and then you have this sort of post production refinement, I think is the best way to describe it. So do you have to change the way that you do your methodologies to be able to run more efficiently, etc. So every time there's a little bit of a compromise and a little bit of I'm not saying kind of cutting corners, but it is sort of that kind of thing, and that's fine. That's the normal process of going from something that works in theory to what can work in practice.
Hmm. So, I mean, exploring that, the handover between quants and tech. It's something I've seen in my career plenty of times in the context of data scientists, communicating with technology people who take stuff through to production. It sounds like you've observed the kind of tensions that emerge. When does it work well, and when does it not?
Okay, I can explain when it doesn't work well. I've seen quant teams go, right, technology are rubbish. They don't know what they're talking about. We're so clever. We're so efficient. We'll build everything ourselves, and that's a terrible idea. Really terrible idea, because one of the aspects is that they just end up with very non-functional code, as an example, because they're too busy being clever rather than being sensible. So I think the handover is, and I can imagine from a technology point of view, it's it's like thanks very much. We have in particular in banking, where you have so many checks and balances mandated by regulatory authorities, that they nobody sees that, and I think they get a bad rep for the amount of stuff that they have to do just to keep their regulators happy. Whereas the quants will go, oh, it doesn't really matter because I'm so
Mhm.
clever, kind of thing. So that handover is very important, um, but there is tension, and I think the hardest thing is to get quants to write to technical standards. So if like JUX is heavy on functional coding, that's a classic example. It's like, no, you're going to have to write this functionally. And where I've seen it, happens to be Scala. One of the firms I worked with happens to use Scala quite extensively. They were pretty disciplined in how they build their functions, and I think that's. But again, it's sort of it doesn't quite work with quant mindset.
Mhm.
That sort of restriction, but it is necessary. So you're going to have to sort of operate around the edges a little bit on that. But at the end of the day, you have to remember that it's the technology guys who are going to have to run this stuff. And so it's that sort of, it comes back to that responsibility thing versus the accountability. The quant has to own, there has to be accountable, but somebody's got to take responsibility to run this thing, and they have the right to insist on certain level of handover or quality.
Oh, it makes sense. I mean, the number of times I've seen a Jupyter notebook kind of running on a production server owned by a data science team that, some tech team has to take ownership of, and painstakingly go through line by line.
Oh no,
Like,
no, but come on, honey. My code is my documentation.
yes.
If you can't understand my code, you should be in your position. It's an absolute quote I've had in the past. Um, Incredible. But yes, Jupyter's running Jupyter notebooks in production is just it's not a good. It's it's very silly, very very silly.
And I'm curious, and for those outside of banking, what is the difference between a quant and someone like a data scientist?
It's getting quite blurred, I suppose. Most quants traditionally have been people who understand stochastic processes. So, particularly in derivatives, where you have to, in many ways, forward propagate your interest rates, out to whatever 20 years or something like that. And it's the same with equities. You need volatility. You need to create again. You need to forward. So everything in derivatives is you propagate a distribution forward to the maturity of the contract, and that particular type of mathematics, stochastic. It's very very separate from statistical, obviously, and data science is sort of more on the statistical side in many ways. I would say it's sort of, but there's definitely overlaps. But when we talk about quant, it's very much a sort of a derivative kind of mindset.
And stochastics and playing interest rates forwards, this sounds like you are building a model of sort of emergent processes, recursive processes. Is that the kind of
Yeah,
specialism?
yeah. So if you um, we'll do a 2 minute detour onto this. So if you've got a swap option, this is the right to go into a swap at a certain level in the future. So you have to decide. Let's say it's a swapping into a 5-year interest rate swap. You've got to decide what is the distribution of where that 5-year swap can be at the maturity of your option. And then, of course, then from there you'd say, well, I've got a strike price. Therefore, if it's below that, it'll be out of the money. And if it's in, then it's got this type of value. And so you get a distribution of values with a bunch of zeros at the bottom, and then you sort of PV those, present value those, and that's the value of your contract. It's really it's really just that simple. Yeah, I wish it was, but at its simplest, that's what they're doing. Where it gets more complicated, they say, well, what about the thing will knock out at certain levels, or remember those sort of caps or caps and floors they used to have on mortgages before your day,
Yeah,
Henry. But
indeed.
accounts and floors, so that's like we call it like a whole collection of little options. And again, you would have to find a way to say, well, where will these little caps and floors be in 10 years' time?
Hmm.
And I have to value that today for that probability. So that's what derivatives in a nutshell.
Thanks.
And then you just add in counterparty risk, and you just make the whole thing a multi-dimensional
Just add in the
problem, and,
poly-risk.
and off we go. Yeah.
Thank you for that detail. That was great. You mentioned AI earlier, and obviously we have to talk about the rapid adoption of AI and machine learning in banking. And I'm really curious how you see these technologies as either helping or hindering in the evaluation of risk.
Yeah, I sort of depends which side of the bed I wake up on, because I'm sort of schizophrenic. It's probably the best way to describe it at the moment. So I'll do the downside first, and then we'll talk about the upside. So the downside for me is the efficiency paradox. I think I mentioned earlier, where you get this sort of bounce in efficiency because, oh, look, they can, AI can write my documentation, and it can, et cetera, et cetera. Or I can write a snotty legal-esque email to the parking people in my, all that sort of stuff. And so you get this sort of bounce because obviously you would have to pay for that. Now it's for free. And I think from a coding perspective, I've fallen into that trap. Just watching the code being written and just think it's amazing. But if we go back to what happened with the Excel adoption, everybody went, "Oh, fantastic! I don't need IT anymore. Just give me the data and I'll run it." And the problem with that is you get these very complicated spreadsheets that do something which is strategic in many ways, and then the person leaves. And then you got this people like, oh, I don't know what to do with the spreadsheet. It's not audited. It's no documentation. It's a I got it. So that efficiency gain, you get that bounce at the beginning, doesn't when you look at the full life cycle, is actually paradoxically it's actually negative. So we got that recent experience uh, with Excel, and I think we're in that first stage with AI because we've all used. I love Claude and Perplexity in particular, and I've used Grok and ChatGPT, and I've been trying to find how to use things efficiently. So I know I don't need to have a team in offshore team of data scientists and coders because I just get Claude to write it for me. So, but I also know that I don't think the code is particularly good. It doesn't have sustainability. So it's throwaway code and should be treated as such. I think it's good for POCs, but if you're going to get serious, you need to, as we said, you need to have a warm body doing it properly. Properly functional code, properly tested, properly this, properly that. So I think it gets you to first base. But if you rely on it, was it the T app or something like that in America? That they did this had this new app, and people put all their details on it,
Right.
and it had
Yes.
zero security. So
Vibe coded straight through to production.
exactly, and it was like people say, "Oh, it got hacked." No, it didn't get hacked because there was no
Insecure by
security.
design.
it was like you just went on the website, just grabbed everybody's data. So I think those kind of things has been a good warning to you've got to be very careful. And I think AI has a huge potential, but you have to know where the warm body is. And that's and I've noticed this with AI, particularly LLMs, they're a bit lazy when you ask the first question. And I think it must be an energy, technology, la la la. But they are lazy, right? It's only when you start to prod them do they you get the full information. So you have to be an expert, or you have to be a knowledgeable person to know that you're trying to push the AI to get the information that you want. If you take it as first pass, then it's no better than a Google search.
Hmm.
So I think we're going through that process at the moment. Does it have huge potential? Yeah, I think so. But you have to decide whether you want to be in the driving seat, or whether you're happy to let it do it for you. And I think if you choose the latter, I think there's very, very limited upside.
It's interesting what you say there is mirroring a lot of the recent studies into the impact on developer productivity using AI, where individually they can act as enormous accelerators, but team dynamics and the bottlenecks of organizations can mean that even if things are working well, and it's a if you like a good application of AI in the software development lifecycle, um, you might not realize that much benefit. But at the moment, it seems that as a thinking tool, as a way of domain experts in as aiding in their development, the
Yeah,
results, the empirical results seem pretty good. I just think that seems to be mirroring your
I,
experience.
yeah, I think so. I say, but the first book I wrote was on it's called Weather Patterns to Physical Risk Swaps. It's 80,000 words, and it's in the open source. God bless Finos. And the research. I built my own chat and had about 2,000 books on the topic, and I use it as a research tool with Perplexity.
Hmm.
Otherwise, there's no way you can do that as an individual. But it was a very good way to pull the information that I wanted, and also have all the citations, which was very handy. We like that. So that's a good example because it just accelerates. Somebody I happen to be an expert in that space, so it just accelerates the information gathering. And but when you start asking people like, oh, do my homework, on, then it's going to be very, I don't know what the universities are doing at the moment. It must be
Yeah,
hugely
yeah. That's
frustrating.
as you say, we're figuring all this stuff out, but it does seem to be an amplifier in both directions. If you are asking good questions and paying attention, you
Well, it's
can.
bizarrely, it's your garbage in, garbage out.
Yeah, in a way.
Ask stupid questions, you'll get stupid
And
answers.
it's sort of recursive as well. If you keep asking it to do your homework, you're getting worse over time.
Yeah.
Um, so that seems to be focused on the development of models supported by AI. But is AI actually having any impact on the models themselves? Is it being used to predict risk?
Yeah. Not really at the moment. I would say, models are, AI is being used in things like algo trading. That's the classic one. So and it's been used in um, anomaly detection. I built one about 4 years ago now. Didn't get sold. Anyway, it doesn't matter. So it was actually, I thought it was really good, but and this is picking out things like front running in terms of people get orders and they buy ahead of the client, make a bit of money, and then sell the stock to the client. So it's very naughty and illegal. So you need a way to sort of understand patterning, things like that at speed. And so I think that kind of thing is really good, but it's very, very controlled environment, I would say. Uh, they do use it for mortgage applications. It's a classic one, or lending, and there, I think it's quite problematic, or can be quite problematic, because you can sit there and go, well, I can use say 2,000 parameters, but actually you have real problems with data quality, or the consistency of data quality, and bias, and all those kind of things. So the art of getting down to a sensible set, is art. Funny enough, rather than anything else. So I think those kind of things, KYC clearly, that's where it's been mostly used. Where it can help, I think, is in operational risk. We're starting to start talking about, checking, Jira logs, production statistics, production issues, client contacts, things like that, and using that to way to, um, you know, dashboarding, and you know what I mean. It's escalating, like there's something going wrong here.
Hmm.
So I think, but all those are sort of a variation on regression in many ways, or maybe including emails as a bit of LLM, but it's quite regression based. Uh, but again, I don't. I'm still struggling to see where, if you've got a risk taking exercise that's fundamentally flawed in the way that it's being perceived, AI is just going to make that worse. It's going to amplify. So at least you get to the point where it's blowing up a little quicker, which might have some sort of societal benefit. But it does feel, uh, when it gets embedded into particularly capital markets, I think that's when people are being very, very cautious, and the banks are very, very cautious, because if they do make a mess of it, the regulator's going to be all
Hmm.
over them, and it's going to be a big trouble. So I think that they're taking it a cautionary road, and I think that's by far the best thing they can do at this stage. But as I said, it's a great tool. It really is.
Now, earlier you mentioned product valuation models. Can you remind me what those are?
Okay, so PVMs. So um, it's the process of taking a product which you have sold to a client. So it could be a structured note, or it could be an equity option, or a warrant. And once it gets into the risk system, you've got to allocate it's market data, which will include data that's been derived, as in a curve, and the algorithm that's going to calculate it, and then what sort of parameters you're going to get out of that. A lot of those parameters get aggregated alongside other products. So if you've got warrants, it'll be aggregated with the equity holdings and other options from different products and things like that. So that aggregation process is hugely important in banking, because when you look at capital, they allow quite considerable amount of netting. So you can have a book, of you know hundreds of billions, if not trillions, of longs and shorts, but they net. And as I say, you better be right.
Well, so this brings me on to the question, really, which is once these models are in live in production, how are we making sure that they're right? Like, is
Yeah,
there a case for ongoing testing, and how
yeah.
does that work?
It's less testing but more monitoring. So it comes back to that. Is the model performing? So the best test, if you need one, is attribution, P&L attribution. So what they do here, they take a Taylor's approximation. So they take all the sensitivities, and they say, well, how's the market moved over the day, and therefore I can go, delta times, da da da, gamma, blah blah, vega, theta, etc. And I can estimate the P&L, and you can compare that with the actual P&L, and that variation, that noise between the two, is quite a good indication whether the model is performing or not. So other tests or other monitoring is the speed at which they're calculated, and the other type is to look at time series of sort of model input, and how the sensitivities are, whether they are unstable or not. So there's all these sort of, not red flags, but whatever, amber flags, let's call them that, of, well, this looks a bit odd, or
Hmm.
it's not this. Um, the other one is just activity, and it's a bit harder to kind of explain. But if you mispriced something,
Hmm.
right, and everybody goes, it's amazing how much market share you take, because everyone's going, really? Well, okay, I'll fill my boots. Thanks very much. And so you get these sudden spikes in activity, and it can be an indication that whatever's happening, the world has moved on in terms of recognizing risk, which your model hasn't. So skew is a very good example in back in the day. when models didn't appreciate the fact that out of the money options trade on a different implied volatility, and they feel up the boots to the point when they realize they made a mistake. Um,
It's
so I
quite a
think
lagging indicator that. Are there
it.
any
Oh yeah, yeah.
leading indicators?
It's definitely lagging. It's definitely no holy Moses. We who's we have a problem here. So yes, most actually all of them are lagging. I have to admit.
Right.
So the only thing you have up front is the knowledge of the weakness of the model and its limitation of use. So that's the limitation of use is very easy to monitor. It's like you're not allowed to use this model in this way, or you can't have a product that has a maturity more than 5 years. It's a classic example of that. So it's like there's too much model uncertainty. 1 year trades, 2 year trades. If you get it wrong, it's short term. But if it's 5 years, then we're going to have 3 years of the model being wrong. So let's just do 2 years, and that's a kind of a classic mitigation. So I think there's a lot of mitigation things you can do. But as I said, from the beginning of this conversation, when models blow up, it tends to be a surprise, and it tends to be brutal when it happens because nobody knows why, or very few people know why, and it's very costly to unwind.
Hmm.
And that's
So we're talking really about the return on investment of good model
yeah,
risk governance.
yeah. So I think from a vendor's point of view, what we've noticed, the first thing is you get assurance to the leadership board that what the things that they probably don't fully understand. I'm not being rude here, but because they're they're running a business and that they won't have the time to get into the details, or they'll have to say some do, to their credit. So they need a group just to check that it's all going fine. So that's nice to have in many ways. I wouldn't say that's a return on investment, but it's definitely nice to have. The other side of it is when you start talking to when you have an RFP as an example, and they go, oh, this is a good piece of kit, we need this data, blah blah blah, and sort of towards the end of the sales process they go, okay, well, we need to pass across to the model validation team. And if the model validation team find out that you actually have a model risk governance that mimics what they do, because what all the things, all the templates and all the stuff in my book is just an aggregate of client engagements and being in banking over the years. So they would recognize, they might not be exactly what they have, but they recognize what we are doing. It means that there's a trust there,
Hmm.
and that trust is hugely important because people don't fully appreciate that the banks own the model risk of their vendors. Yeah, so they can't pass it off to the vendors and blame them. The regulators won't allow them. So that model validation person or the model risk person owns your risk. So they can ask questions, and if you palm them off, say, "Oh no, they just need some testing results and some user guides, and just we'll just give them what they want," you're not going to build trust. And what we found uh, is that if if you can talk to them in their language, your sort of model related artifacts are what they would do. That means that they have that trust. So you're not on. We used to call it, like, don't be on the naughty chair. Yeah, don't be that. And when you're making changes. I mean, I've been in a place where we changed all the models, all the data, and the calculating agent in one go. It was quite amazing, and we got almost no feedback. It was ridiculous because we told them what we were doing, and they had the trust that whatever we were doing was going through a model governance process, in addition to all the testing and all the migration stuff. And that's competitive advantage because you're building a partnership, trustworthy partnership with your clients.
Hmm.
So that becomes very sticky. So we see that as the ROI, and also as I said, when things go wrong, we have the framework to solve things quickly rather than having everybody running around panicking long email chains. You know what it's like. So that's the sort of the importance. But we like the idea that we have salespeople now that go, oh yeah, we have model risk. Oh yeah, of course. When we've been doing it for 5, 6 years now, and it's mature and it sort of just makes the whole process go through quicker.
Is there a danger that it's a barrier to innovation if banks are looking for their vendors to do what they would do? Does that act against new solutions that might be an improvement?
Um, that's a very good question. I haven't really thought about it that way. I'm going to say no.
I guess if
I
you've
guess
built trust, maybe you
yes,
have a bit of latitude if you can
yeah.
explain why something
I,
is
I
an
I would
improvement.
say read my book. No. So I'm just kidding. Um, yeah, but the banks, the banks like the idea of innovation, but they have responsibilities to the supervisory bodies. So um, that's so actually I think it makes things easier, and the key to this is to be proportionate. So and again, is because the problem some of the particularly some of the smaller firms go, we can't afford this. This is crazy. And I said, well, we the S 11.7 is very much like you have to do things proportionate to the risk that you're taking.
Hmm.
Um, but doing nothing is not a good idea. So you need to do something. And I am always advise my clients to you know start small, and particularly when you've got firms that have like a quarterly release cycle and things like that, you have to adapt to that, and you certainly can't be the group that stops that sort of process. So you have to find ways to add to the process
Hmm.
without making it a tax. And so it's hearts and minds a lot of the time to get that to work. But it has been well, it's fascinating. It's a fascinating world. Um, but also we think it sort of certainly adds value. So I think it actually improves. I think it makes things because um, it avoids maybe it does, maybe it avoids mistakes. I don't know.
What developments are you most excited or concerned about the next 2 to 3 years? You're deeply embedded in model risk management and open source and finance initiatives.
God, oh God, yes. Next 2 to 3 years. So I think let's take Finos because obviously that's it's coming up. They traditionally Finos has been very much I'm not being rude here, but it's very much the back end. It's how companies and their and various entities talk to each other when it comes to product life cycle. So this is what a CDS looks like. This is what a message looks like. This is what a payment looks like, etc. And here's all the rules um, to enforce that whatever system you have, once it gets into CDM form, it's going to work. And I think that's been. I wish we had it 20 years ago. I really. It's one of those things like if only we weren't crazy enough, but it is what it is. So that part of Finos I think is very exciting, and we are expanding that out to involve properties, mortgages, and flood events, gauges, interestingly, um, and insurance, and have it in the CDM. It's common domain model, um, and I think that's the bedrock for us to then build um, flood related contracts, things like that. So I think that's exciting because for once in our in industry's life, we're sort of getting the basics. I know it's
Sort of shared
crazy.
standards, shared language and vocabulary.
Who would have thought, eh? Who would have thought? Crazy world we live in. So I think there's that side. That's the physical side, which I'm heavily involved in. So I'm very excited by developing that. I think the other side is the AI, the AGI governance side of things, where um, I haven't really gone into the details and what they're doing yet because I think that they've only just announced, or they will be announcing in a couple of weeks' time. But the fact they're getting everybody together and deciding what what a governance should look like for AI or AGI sort of um, deployment is a very, very strong thing. So I would love to see funny enough, the two sort of to merge, that we have a common standard of how you do model risk. So instead of like individual firms going, well, what am I going to do with this? There is a much more sort of an industry response. Say, okay, I've got my JPs, Morgan Stanley, Goldman Sachs, Citi, etc. Going, okay, okay, what do we think if this comes our way? Like, a good example is flood data providers. So what do we demand from that? Let's just all agree, have the same sort of response, and that's and also to pull in the regulators to say this is what we're thinking about this type of data, and this is our demands. And I think that sort of openness, because if you feel the need that we really do need to get going on climate related issues, then everybody agreeing rather than going off individually seems like a good good investment. And I think Finos is perfectly placed for that. So I think that definitely the AI stuff, definitely the physical risk, and that sort of model type stuff. So it's a bit of a, I say, it's a bit of an expansion of where Finos has been before. But I think it's quite exciting. It really is, um, because it's a cost thing, because standardization is good, but it's also a risk thing, because you've got more minds thinking about these things, than sort of people isolated in individual firms. So I think that's going to be right. I think on the AI side, well, you know, sometime fairly soon something's going to go horribly wrong, right? So I'm excited for that, because I hope it's not me, but also means like, well, we told you so. You know, you should have had these things in place, and da, da, da. So hopefully, for my own personal, that we'll certainly get more business to tidy up other people's model mess, I guess.
Watch this space.
Yeah,
Okay, David. Well, thank you very much. I've really appreciated the overview. And we mentioned Finos a few times, and we're looking ahead to the Finos conference later this month,
absolutely.
OSFF conference in New York. Reminder, it's the 21st and 22nd of October. I'll be speaking, actually, about accelerating the adoption of the Finos AI governance framework. So hoping to mitigate some of those risks you were talking about. If you're at the conference, do come and say hello. Otherwise, look forward to seeing you on another podcast soon. Thanks, Dave.
Okay, thank you for having me. Bye.